Hello and welcome back to another episode of Math with Sohn. Today we're going to be learning about a little bit more of a complicated thing with friction in physics, and that will be what is the force of friction with an object that is sliding but has this angle in which it is being pulled from, okay? And so how are we going to deal with that, all right? So a few important things to recognize. The first thing is that when you have an angle, that means that some of that force is not going to be applied necessarily all horizontally or all vertically. It's going to be a combination of both. Okay, so if it was just straight horizontal, we're going to first start by drawing a free body diagram. Then your force of friction would be opposing this, and you would still have your force of gravity. You would still have the force of natural, and on top of that, then we would have this rope pulling on the object, and that would be the force you actually applied, because you're applying that force on your actual rope, but it needs to be separated into two different components, the horizontal component and the vertical component. Well, the horizontal component would be F cosine of theta using basic trigonometry, SOHCAHTOA. Cosine is adjacent over hypotenuse, and therefore when you solve for that, you would get F, the hypotenuse, times cosine of theta for the adjacent part, and this part would be F times sine of theta. All right, that's very important. So with that in mind, what is the actual normal force? So if you're pulling upwards on this rope in this direction, that would mean that some of gravity is being counteracted. I don't know if you remember the elevator problem we did, but whenever you're moving upward or pulling upward, that would counteract the gravity, and therefore you will not necessarily weigh as much. This block is not going to weigh as much. Therefore, the normal force is not going to be as much. All right? And with that in mind, another thing to consider is this block is still on the ground. Okay, because it's still on the ground, we're going to write something very important here, and that would be the sum of all forces in the y direction would be equal to 0. When you see that, that means that the object is stationary. The sum of all vertical components cancel each other out. All right? With that in mind, that would indicate, I like doing this part and jumping straight to force natural. The natural force would equal what would have been gravity by itself. And what's counteracting gravity is we are pulling up on this rope, which means we have some vertical component here, which is F sine theta. That would be counteracting gravity, so I'm going to do minus F sine theta there. Okay? So, another way to rewrite it, and what sometimes AP Physics likes, is that you would rearrange this formula so that it would equal 0. I like this one. This one makes sense to me. But you will also see a formula that indicates this, where if we subtracted this Fn over, you would have 0 equals mg minus F sine theta minus F of n. Like if we took away and combined all of those things, we would end up with 0. All right, next part. This is the more important part. Derive an expression for the acceleration of the block. So the acceleration of the block indicated by everything that's occurring. Well, the block is accelerating in the right direction, on the way to the right. It is not accelerating upwards. We already determined this block is on the ground. So it is accelerating only to the right. And the way we're going to be figuring that out would be if the sum of all forces in the x direction or the right direction, that would equal just its mass times acceleration. Okay, so after all friction has occurred, its acceleration would be mass times acceleration. Its mass times its acceleration after friction. Well, what would be its mass times acceleration after friction? Well, that would be the horizontal force out of this tension in the wire. So this horizontal force is F cosine theta. But we need to subtract its force of friction. Well, what's the force of friction? That's the part we need to figure out. Well, the force of friction is typically its mass times acceleration, like the mg part, times its kinetic coefficient. Well, what is its kinetic coefficient this time, and what is all the other stuff that we have. For starters, let's go up here. This force of friction is really its kinetic coefficient times the force natural, because you're only going to be battling the friction based off of the actual natural force. And the actual natural force we just determined up here. We have to take what it would have been, its mass times gravity, but we have to take away how much we pulled upwards with it. So we are going to put all of that right here. So its mass times acceleration will equal F cosine theta. That will be how much we pushed it horizontally, pulled it horizontally, minus mk times this whole thing, the force natural. The force natural is mg minus F sine theta. So times mg minus F sine theta. All right. With that in mind, we got some simplification we could do. We could distribute this if we wanted to. We could also just leave it ugly if we wanted to. It just says derive an expression. So in order to derive the expression, you could divide all of this by mass, but you could simplify it more and more if you wanted to. I'm just going to take the lazy way out and divide this whole thing by mass. And you'd get your acceleration is equal to the cosine part, how much we pushed it to the right, minus the friction. And that friction, again, as a reminder, is only the portion that was affected by friction, which is not the full natural, not the full mg, but take away that mg, which is the F sine theta, and then divide by the overall mass. And that would give you your acceleration. And that seems like enough for one video. In other videos, we're probably going to influence some numbers. This is just the how to derive the equation, but if you had numbers, you could plug it in. It wouldn't change anything. The next thing we have to deal with is, instead of it being pulled up on an angle, being on an angle itself, which flips the script. If you haven't already watched the video on how cosine and sine affect this, I would highly suggest it. I've done enough rambling for one day. Until next time, stay positive, my friends, and I will see everybody later. Bye.